Okay.
So this creates an interpreter which still has the bytecode loop which was here. This gets translated here. For Python you have several problems, like for arithmetic intensive kind of algorithms, it's really 1,000 times slower than C, and bytecode dispatch is only responsible for maybe a factor of 2. The rest is the runtime overhead,
sure.
Everything is boxed and so on. So you can only go so far by removing interpreter overhead, but we'll say more about it after. These are the goals of the project. The first goal is probably the most important one, the one which started the whole project. And what is nice in this project is that we have actually written something which is completely independent on the host. There are no early design decisions, if you wish. We've written an interpreter which just is written in Python, so it's already a high-level language, so there is no low-level design decision, like, for example, what will be the memory model, what will be garbage collection, reference counting neighbor. It doesn't really matter for the high level. We have written this. It's completely independent. And, well, as I said, you can actually modify the interpreter, make small or large change to change whatever language you're interpreting. And then, during translation, you can actually add these low-level things, like, for example, choose a specific memory model to translate your interpreter, your internal interpreter structures to. And this is, well, I mean, then you can start thinking about what are the best GCs out there. Can we experiment with completely different GC, with different memory models all together? Can we change the object model? So it's an extremely flexible platform, essentially. It's saying that when you're thinking about virtual machine, you don't necessarily have to think there is my OS, then there is a virtual machine, then there is a program that I run. The virtual machine here can be generated, produced in very interesting ways. You can actually, from the virtual machine that you have defined at a high level, like, for example, in Python, you can add features that depend on the host runtime. So, for example, soft threading, meaning that if you take your program, your virtual machine, which is written in Python, which does recursive call all the time and so on, you can translate it into, for example, C code that use continuations. So you can add continuation style at the low level. Doesn't necessarily mean to be a design decision that changes your whole virtual machine. You just add a feature. And the most interesting point is maybe the last one. You can actually, at translation time, change the semantics of the virtual machine and transform the virtual machine into a just-in-time compiler. So your interpreter can become a just-in-time compiler after translation. And this is so because compilers can be implemented by abstract interpretation. So you can write a compiler for some language which looks very much like an interpreter for the same language. I mean, you could take an interpreter for a language and do some kind of mechanical translation, obtain an abstract interpreter for the same language, which, with some tweaking and some support library that you will have to write manually, can be a just-in-time compiler. And this last point is actually fairly concrete, in the sense that there is already a project that I'm the author of, called Psycho, which is such an abstract interpreter doing just-in-time compilation for Python. So the goal is to actually recreate a project like Psycho using these techniques. So essentially, now we have a way to derive a just-in-time compiler from just a naive virtual machine, just a naive interpreter for any language. Well, in interpreted, object-oriented language, imperative, object-oriented, this kind of language, I guess. It's probably a bit more difficult, but not. I think I will look into Prolog more extensively. I think it's possible. I mean, there are things that could be done. So now, if we say just writing an interpreter is nice, and we can do a lot of cool things from it, then it means that our nice interpreter can actually be very modular. People can actually add things into it, and go again through the same process to actually generate a low-level equivalent of it with just-in-time whatever. So you can actually, it's extremely flexible. You can actually add features to your interpreter very easily. Among the features that are classical are features that you would put usually in middleware layers above the interpreter. For example, persistence or security. For persistence, for example, for Python, it's already possible. You already have persistent library, but there are kind of hacks using the meta-class model of Python and hoping the user won't look too closely or do some very silly things. This is the kind of thing that you can more or less do with, in regular Python, with regular classes and so on, but this is the kind of things that are better done inside of the VM, obviously, at the same level of the VM. And this is the kind of thing that this project enables. For security, it's completely obvious. If you can, for example, add a security check at every access to such attribute of such class, or more generally all attributes and these kind of things, this is best done inside of the VM instead of at the same level as the user program. The current status of the project, the interpreter core is more or less ready, works nicely. The R Python, which is the Python language in which we promise not to be too dynamic, this analysis by abstract interpretation and type inference just works fine. And we are working on code generation. We have various backends actually developing them in parallel. The most advanced one, but the most recent one too, is generating C code. And we could generate, the plans are to actually generate Java code and generate .NET code to actually recreate the equivalent of the Jython and the Aaron Python project. So we don't plan to actually subsume either of these projects, not in the short term, but provide new ways to target these platforms and compare. It's really an experimentation platform. And this is my position. Essentially, I don't like the idea of a single virtual machine or host environment or whatever. I think that with the correct language-based tools, you can just actually have to target whatever you want and just try around, experiment. And this is more hand-waving. If I say that we should not, that there is no point in standardizing in a single virtual machine or whatsoever, the usual answer to this is, well, virtual machines are nice for interoperation, and what I do think is that you can actually do interoperation by focusing more on language techniques as well. This is an example. This is a bit strange example. I mean, I don't have very concrete examples, but let's try. So each of these three language or platforms have their own notion of class, for example, and they are all slightly different. You cannot completely map them from one to the other, but you can do something. For example, the Jython guy who implemented Python into Java did something that can map between Java classes and Python classes. Mapping is not perfect, whatever you want, but you have some kind of mapping. So if we take this mapping here, if we take this mapping and write it in the context of the PyPub project, we get a transformation from Java classes to Python classes and back that can be compiled down to some PyPy version compiled for the Java virtual machine. And well, if independently we do the same thing between Python